This video is about the Fermat point, which basically is a point, any point f inside a triangle, such that fa plus fb plus fc is minimum. A, b, and c where are the vertices of the triangle. Now to solve this problem, let us say that fa plus fb is equal to z. So if fa plus fb is z, then what we are now going to do is we are going to find out all the points p or the locus of points p so that they satisfy this condition that pa plus pb is equal to z. Now, of course, because if this is the condition that we want point P to satisfy, then it will automatically create an ellipse, because this is what is the definition of an ellipse. So the locus of the points P is going to create an ellipse. Now, why do we want an ellipse over here? So the reason why we are trying to create an ellipse is because we want to use the reflection property of ellipse to calculate a relationship between theta 1 and theta 2. Our point F, which is the point which is going to satisfy that condition, fa plus fb plus fc, it is now lying on our ellipse. And we also know that for any point p anywhere on the ellipse, pa plus pb is constant, and that constant is equal to z. However, only for f it happens that z, which is the sum of p plus pb, plus fc, this is fc, plus fc is the smallest. If that has to be true, then fc has to be perpendicular to the tangent on ellipse. So if this is correct, then from the reflection property of ellipse, we can also prove that theta 1 is equal to theta 2. Since this is true, we can also say that angle AFC is equal to angle BFC. So this one is the angle AFC, and this must be equal to angle BFC. Now we can extend the similar argument, we can extend the same argument and then say that angle BFC, this is the angle BFC, or you can see it over here as well, is equal to angle AFB. So what does that mean? That means that in our triangle, theta 1, theta 2 and theta 3 are all same, and their sum is equal to 360 degree. Since their sum is 360 degree and they are all same, theta 1, theta 2, theta 3 must be equal to 120 degree.